Welcome, curious minds, to another deep dive. Today, we're plunging into one of the really exciting frontiers in large language models, LLMs for short.
Yeah,
You've probably seen how powerful they are, but you might also know they can sometimes, well, hallucinate information or get stuck on tricky multi-step problems.
that's right. And these aren't just small glitches. They're fundamental issues tied to how LLMs actually store and work with knowledge. Our sources for this deep dive, they show how researchers are tackling this. They're bringing together two really strong approaches, Retrieval-Augmented Generation, that's RAG, and advanced reasoning techniques.
Okay, so our mission today is to unpack how these two ideas, which started out separately, are now being combined, synergized really, into these much more dynamic systems. We're leaning heavily on a big survey paper called Towards Agentic or with Deep Reasoning. It gives a great overview of this whole area. So let's dig into this shift and see how LLMs are getting smarter and hopefully more trustworthy. Right, so we know LLMs can sometimes make things up or struggle with complex stuff. What were the first stabs at fixing this?
Well, the paper highlights two main early paths. First was RAG, Retrieval-Augmented Generation. The idea there was to give LLMs outside knowledge, like a factual safety net. And the other path was boosting their built-in reasoning skills, teaching them to sort of think step by step.
And these worked mostly in one direction at first, right? Kind of a one-way street.
Yeah, that's a good way to put it. You had reasoning-enhanced RAG, where the thinking part helped improve bits of the RAG process, like making the retrieval step better. And then you also had RAG-enhanced reasoning. That's where the retrieve facts just helped the LLM's reasoning along, gave it some grounding or context.
But the source points out this retrieval then reasoning or RTR approach had its limits. It was a bit static. What were the sticking points there?
The main problems were, first, the knowledge you pulled up beforehand might not actually fit what the reasoning part needed later on. Also, if there were errors in that retrieved knowledge, well, those mistakes could mess up the whole reasoning chain. And importantly, there wasn't really a good way for it to go back and forth. No iterative feedback or dynamic searching. This made it less flexible for complex things, like answering really open-ended questions.
Okay, so this is where the paper talks about a paradigm shift. What does this newer synergized RAG reasoning actually look like? What's the big change?
The really interesting part here is the shift to a dynamic back-and-forth process. It's iterative. So instead of just one system improving the other in one direction, now the reasoning actively steers the retrieval. And then the new information that's found continuously shapes and refines the reasoning itself. It's much more of a loop.
It sounds less like a simple lookup and more like, well, like it's actually doing research. This seems related to those deep research features we're seeing from companies like OpenAI, Gemini, Perplexity, right? The paper mentions those.
Oh, absolutely. It connects directly. These systems use what they call agentic capabilities. That means the LLM can sort of plan and act. It orchestrates multiple search steps, digs through web results, and uses its reasoning to really understand and synthesize all that information. It tackles problems needing that deeper dive.
Got it. Let's break that down more. How does reasoning specifically make the RAG pipeline better? The paper mentions optimizing retrieval, integration, and generation. Let's start with retrieval. How does reasoning help find better information?
Right, so reasoning helps make sure the retrieved stuff is actually relevant and high quality. For example, reasoning-aware query reformulation. That means if you give it a complex question, the reasoning part can break it down into smaller, easier sub-questions. Or if a query is vague, it can rephrase it. Even techniques like chain of thought, where the model explains its steps, can be used to add more context or detail to the query itself, making the search much more targeted.
Okay, so it's thinking smarter about what information to even look for. Then, once it has potential information, how does reasoning help integrate it, putting the pieces together?
Yeah, this part is about figuring out what's relevant and merging the useful bits. The source talks about relevance assessment and filtering. Some systems use assessor experts. Think of them as specialized little models to pick out the evidence that's both accurate and helpful. Others filter out text that doesn't really support the main point, which makes the whole thing more robust. Then there's information synthesis and fusion. Reasoning can help combine different coherent pieces of evidence. For instance, building a reasoning graph to connect related facts.
Makes sense. And the last piece, generation. Even with good context retrieved, the LLM might still generate something inaccurate. How does reasoning help control the final output?
This is crucial. It's called grounded generation control. Basically, reasoning is used for fact-checking during generation, making sure the output stays consistent with the evidence it found. Or it can be used for generating citations, linking the answer back to the specific sources. This really boosts transparency and, lets you trust the answer more.
Okay, now let's flip it. We've seen how reasoning helps RAG. How does RAG, the act of retrieving knowledge, help the LLM's reasoning process?
Retrieving knowledge, whether external or from its own context, helps the LLM cut down on hallucinations, those made-up facts, and it helps bridge logical gaps in its thinking. So external knowledge retrieval means bringing in info from outside sources. Think knowledge bases for factual grounding in Q&A, or even formal lemmas like proven math theorems to help with structured mathematical problems.
Like having access to a huge digital library and specialized textbooks on demand.
It's sort of, yeah. And it also includes things like web retrieval for grabbing up-to-date online info, super important for fact-checking current events, and tool using, where the LLM can actually call on external tools, like a calculator for better math or code libraries or APIs. This expands what it can do accurately.
And what was that other type? In-context retrieval. How does that fit in?
Right. In-context retrieval is about leveraging the model's own internal memory or examples it's seen before. This could mean recalling prior experience, maybe a strategy that worked on a similar problem before. Or it might involve fetching specific examples or training data that show a good pattern of reasoning for the current question. It helps guide its thinking based on past successes.
This whole iterative process, this constant back and forth between finding info and thinking about it, it sounds really powerful. The survey talks about different ways this happens, mentioning reasoning workflows and agent orchestration. Can you unpack those workflows first?
Sure. The paper outlines a kind of progression. You have chain-based workflows first. These are pretty linear step-by-step processes, but the key is that retrieval steps can be mixed in between reasoning steps. This helps stop errors early on from messing up the whole chain. Then you get tree-based methods, think tree of thought. These explore multiple possibilities, like different branches of reasoning at the same time. It's a way to hedge your bets if one path doesn't work out.
Interesting. And what about graph-based workflows?
Graph-based approaches are quite neat. They often use knowledge graphs, these networks of connected facts. The LLM can kind of navigate this graph, using it as a sort of reasoning playground, decides which connections or entities to explore next, building up its path towards the answer in a more flexible, less linear way.
That gives a good sense of the reasoning structure. Now, how are these systems actually put into action? What's agent orchestration?
Agent orchestration is about how the system interacts with the world, like the web, or tools, and how the different parts are coordinated. In single-agent systems, you have one main model managing everything, breaking down the problem, finding information, putting it all together. The React framework was a big step here. It showed how you could guide an LLM to explicitly switch between thinking steps and taking actions, like using a tool.
And if it's not a single agent?
Then you have multi-agent systems. These split the work among specialized agents. You might have decentralized architectures where several agents work together, maybe in parallel, on retrieval and reasoning. This can help cover more ground. Or you can have centralized architectures, which are more hierarchical. You might have a manager agent that breaks down the task and assigns subproblems to other worker agents. This can be really efficient and adaptable.
Okay, with all this complexity and progress, how do researchers actually measure if these systems are getting better? What about benchmarks?
Yeah, evaluation is key. The survey points to a whole range of benchmarks designed to test both knowledge retrieval and reasoning abilities together. These go from simpler tasks like single-hop Q&A, think trivia QA, where you need one specific fact, all the way to complex multi-hop Q&A like hop-hop QA. That requires finding and connecting info from several different places.
And it's not just about question answering, is it? What other kinds of tests are there?
No, it goes further. There are benchmarks for mathematics, testing if the system can find and use the right theorems or formulas. Also for code generation, where it needs to retrieve code examples or documentation. And even for tasks like web browsing. BrowseComp is an example which simulates real searching and tests how well the agent can plan and navigate websites to find information.
So looking ahead, where does the research go from here? The paper mentions several future directions.
It did. A big one is reasoning efficiency, making these multi-step iterative processes faster, reducing the delay. Similarly, retrieval efficiency, figuring out the best way to decide when to retrieve information and how much is needed, avoiding unnecessary searches. Human-agent collaboration is another interesting area. How can people provide feedback or guidance to help steer the reasoning? Plus, just developing more sophisticated agentic structures and capabilities, things like letting the agent choose its own tools dynamically or adapting its own workflow.
And there are a couple more critical aspects mentioned too, right? Moving beyond just text.
Yes, definitely. Multimodal retrieval is huge. Bringing in information from images, tables, maybe even audio, alongside text, dealing with all sorts of document types. And finally, maybe most importantly, retrieval trustworthiness. How do we make sure these systems are robust, even if the external information they find is misleading or wrong? Techniques like watermarking to verify sources are being explored here.
Wow, quite a journey through this evolving landscape of RAG and reasoning and LLMs. We went from the basic problems through those initial one-way fixes all the way to these really advanced synergized systems that loop between searching and thinking.
It really is a significant shift. This move towards agentic systems, LLMs that can plan, act, search, and reason through complex steps on their own,
Mm.
it feels like a major step up. We're building systems that aren't just passively answering questions anymore. They're actively engaging in something that looks a lot more like, well, deep research.
It really does. This back and forth, this dance between finding information and thinking about it, is making LLMs better grounded in facts, more logically sound, and just more adaptable. And it leaves us with a really interesting question to ponder, doesn't it? As these tools get better and better at doing this kind of deep, iterative research, how might that change how we approach learning and finding information ourselves? Thank you for joining us on this deep dive. Until next time, keep exploring, keep questioning, and keep learning.